Mine's from last year. I wore a red shirt this year.
All right, so today we're going to have all the shapes. This is where it starts to get confusing because you have to know, I say rhombus and you have to know all the properties of it. I personally think that drawing them is the best way of kind of knowing it, okay? The consecutive angle sum 180, that's hard to draw, but all the other properties you kind of want to draw, I think. The other thing that gets kind of confusing is you got to remember, oh, if it's a parallelogram, then it also has the properties of parallelogram, okay? So we're going to start with parallelogram. Tell me, every shape has a definition. So we're going to go ahead and write that kind of up in the corner here. What's the definition of a parallelogram? Okay, we would say opposite sides are parallel. Okay, that's the definition. Those are properties. Okay, by definition, what makes it a parallelogram? We gave it its name, parallelogram, because opposite sides are parallel. Properties, we have 4. Opposite sides are congruent. Consecutive.
You sound like that one log from
Angles are supplementary because I'm talking slow.
Yeah.
And I'm sick. Okay. Diagonal, yes, opposite diagonals. Bisect. Pretty sure I spelled diagonals wrong there. And then opposite angles are, you're right. I personally prefer to write, draw a parallelogram and do this. I don't like to draw one for the second one. That's probably too small. You would draw one because I think they get hard to see what's going on if you try to. That's my opinion.
What can you do for the sides and the angles, and then draw one for the bisect? For the diagonal bisect.
I don't care what you do, but you need to know these 4 things. Okay. I personally like to know there are 4 things I need to know about it, and then the pictures just kind of help me out. Another reason the pictures help me out is if I were to take a parallelogram and I was going to tweak it, I can show to myself that I can't make it not do these things. Okay, I can't make a parallelogram. So if I made it super crazy thin, okay, so I tweaked it as much as I possibly could, the opposite sides are still congruent. I can see that. I can see that the angles, opposite angles, are still congruent. Okay, so I like to think in my brain, okay, if I squish it or make it really weird, but follow the rules that the opposite sides are parallel, then is it still true? Okay, when we start talking about, if I say all angles are the same, well, I can see that's not true. Okay, so I think that helps. We have done kites, but I think kites are kind of interesting to compare to rhombuses because
I thought rhombuses were like just tilted squares with all the angles on the sides 90 degrees. That's what I thought.
They're squished. They're kind of like squish squares. Where they're basically squares that are not necessarily 90-degree angles. So I always think of it as like it's like a falling over square. So it's like the supports weren't good, so it's falling over.
My teacher said it was a square, but like this.
Yeah,
Yeah.
but it doesn't. It's not 90 degrees necessarily.
What if it was?
Then it's a rhombus with 90 degrees, which we call a square.
What if it was tilted? It would be a rhombus.
A square on its side? Yeah.
So square.
It'd be a rhombus.
So
A square is a rhombus.
If I lay down on my side,
It would be a rectangle.
if I lay down on my side, it is a rectangle.
Yeah, exactly.
So here's the definition of rhombus. If this is true, then you're allowed to say it's a rhombus. If what's true, what is it? All sides are congruent. That's the definition. So if you have any shape where all the sides are the same, then you're allowed to say it's a rhombus. Okay? You're only allowed to say it's a square if all sides are the same and the angles are 90 degrees.
Aren't circles all sides the
We're not talking about circles today.
same?
Okay, so let's look at kites. Okay? Kites, I kind of, so what's the definition of kites?
Where's that?
Okay.
2 sets.
2 sets
Of opposite,
of
not opposite.
congruent sides, not opposite, right? Okay, so because this is congruent to that, and then this is congruent to that. And then their angles, okay, or the diagonal comes into play. Okay, diagonals are perpendicular. Can I do that? We know what that symbol means?
Perpendicular.
Okay, meaning 90 degrees. What else do we know?
That
One bisected, the other's not.
Okay. And how you say this is kind of up to you, but one, right, one, the angles become congruent to each other, bisects the angles, and the other, the sides. Okay. How do you spell diagonals?
It's up on the paper.
E-I-A-O-N-A-L-S.
It's on the paper.
Where's it on the paper?
By the timer thing.
Yeah. Curve the diagonal of the rectangle.
Oh. Oh, I'm switching my no. It should be on, not no.
Diagonal.
Diagonal.
You know what?
No.
English isn't my first language, huh?
Me
Oh. Diagonals either
That's how you know it's not in the right.
bisect
That's why I abbreviated it.
each other's
What is your first one?
segments, or English is my first, I was just joking, or angles.
How can the little Russian boy spell it?
I know, he's smart.
No, I was.
I get it, I'm not that smart. I get it. No, it's fine.
Oh my god.
You started geometry this time.
I'm gonna have to get a hug after this period.
Not me.
Oh yeah, I'm not gonna get. I don't want hugs from you.
You should hug Carlos.
So you're gonna hug us.
Yeah, hug
I'm
Carlos.
gonna call my
Yeah,
wife.
Carlos,
She'll
we'll
come
give him
over and
a
give me a hug.
Yeah, Carlos. Yeah, hug Carlos. Yeah, hug Carlos in the first period.
I don't hug students. That's how I got sick. Is just being close to one.
You might get swallowed.
Lie. What did I do? You're closer.
Did I miss anything? So this.
There's only one segment bisector though.
So this cuts the segments in half, and this one also cuts the angles in half. So that's why I said it either is bisecting each other's segment or angles. What am I saying wrong? I feel like I am saying something wrong.
You're saying that there's one angle.
Hold on.
You have one set of segment bisectors, and then you have two angle bisectors.
Okay. When you bisect an angle, it doesn't matter as long as you can represent this picture. And we know that these angles aren't congruent. Okay. We also know that these segments are not congruent.
Oh, you forgot to put the 90-degree thing in.
The what?
The 90-degree thing.
You want that in there? That's a good idea.
Can't we say that,
Right, you have it.
so you know the diagonal line that goes horizontal? So can't we say that, the angle on the side of the line is congruent to the other angle on the side of the line?
The angle, this angle,
And the other angle?
and this one?
Yeah.
Yeah.
The top and the top.
Yes, we can say that that's congruent to that.
Why don't we?
Because, I mean, there's a lot we can say, but
Just not a property, goodness.
You're
not a property. Okay.
Yeah.
I-
She is a property. Yeah.
all right, so here's a point that I don't want us to miss. And to speak to Mark's thing, there are a lot of things that we can say that we don't say. Especially because we cut this into triangles. I can say side, 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 that everything, all the parts of this correspond to all the parts of that. Okay. And so forth. And I really thought that rectangle proof we did for the warm up was going to be easier though, because of how it overlaps. It's not as easy, but yeah, we can always do that. So the rhombus, here's the definition. Okay. And I think it's kind of important to have the rhombus next to the kite because they're very similar in what they do, their diagonals.
Not even the 2-inch triangles, cut it in half, those don't look.
Because he's got it rigged. It's not perfect one.
So this is what's kind of interesting about the rhombus is it has all the properties of the kite. Okay. It's 90 degrees. That is congruent to the segment here is congruent to that segment. This one's congruent to that. This angle is congruent to that angle. This angle is congruent to that angle.
Wait, are those two angles correct?
To each other, like this one's congruent to that.
Oh,
Yeah, it actually is. Go ahead.
how come we can't say, look, how come we can't say these angles are congruent?
Because they're not.
I just said.
How do we know?
We could say that this angle is congruent to this one, but we can't say that this one is. And if I made a really, really flat one, okay, if I made one really, really flat, and that's why I like the drawing.
Brody, look at the board.
Can you see that these two angles aren't congruent? Maybe I should make it flatter.
Default ice cream cone.
It looks like my melted ice cream cone.
That's such a default ice cream. She just disappeared.
What? Yeah, I see
That
that.
looks
Yeah.
like when Donald was
So Mark made a good point that this is actually just congruent to that, which is congruent to that. And then these angles here are all congruent. Okay. So what do we call this? Where-
all congruent angle.
Where it cuts it in half at 90 degrees. So we can say in one statement that the oh my gosh, I forgot the A now, are perpendicular bisectors of each other. Again, I like the drawing. The words make me crazy, but
You're right, we should not use words anymore.
Yeah, I hate them.
Bye, Raleigh.
I honestly think I'm awful with words, but I think that's why I'm so good with math. Huh?
No good.
What else do we know?
all angles are congruent, like the top and bottom angles are congruent.
Okay, so what created those angles?
Bisector.
Okay, so the diagonal
Hate the word that.
bisects each angle. So bisects means cuts it perfectly in half. Now this is where it gets kind of tricky. Is a rhombus a parallelogram?
No.
It is. Okay, because opposite sides are, and I'm not showing it here, but opposite sides are congruent.
Could we say that a rhombus is a kite, or a kite is a rhombus?
No,
But they aren't parallel.
because a kite does not have opposite sides congruent.
A rhombus is a kite.
So I'm going to write for this rhombus, the third thing is plus 4. What do I mean? Because it's a parallelogram. I can say this rhombus has opposite sides parallel. I can say it's got opposite sides congruent. I can say consecutive angles are supplementary. I can say diagonals bisect each other. I can say opposite angles are congruent.
Are all rhombuses parallel?
All rhombuses are parallelograms because a parallelogram, anything with opposite sides are congruent, is a parallelogram. Okay.
So circles has opposite sides. I can circle on sides.
So plus 4.
A circle isn't just a giant side.
Exactly, that's what I said. So all sides are congruent in a circle. So a circle is a square.
A circle is a square, but a circle doesn't have anything.
All of them trapezoid.
So
All angles are
trapezoid. So it's important now, once we move forward, that a trapezoid is not a parallelogram. So because it's not a parallelogram, actually I'm just going to put an arrow. Because it's not a parallelogram, guys, please. Because it's not a parallelogram, we're not going to say the plus 4, right? Now it might have some of those properties, but we're not going to say it. No.
What about plus 2 and skip?
What's the definition of a trapezoid?
One set parallel sides.
One set, oh my gosh, I can't spell it.
Ooh, I know.
Set of parallel sides.
Oh, I thought you were saying congruent sides because none of
Okay. What are the properties of a parallelogram? Yeah.
the consecutive angles are supplementary.
Consecutive angles are supplementary. So this angle plus this angle adds up to 180?
No, the other way.
Okay. So yes, that's true that these add up to 180, but though not all consecutive. So how do we say that? Okay. Can we draw it? In this case, I think a drawing might be better. Go.
That's not an what? That's a nice one. Oh, it's a triangle.
So why are the bottom ones not 180?
Because, okay, so the reason why these add up to 180 because they're same side interior, right? But if this is a transversal, these lines have to be parallel for that to happen. Okay. I don't think trapezoid had many other properties.
You have to write the same thing for isosceles triangle.
Say it one more time.
For an isosceles trapezoid.
Yeah.
Isn't that what you do right there, an isosceles trapezoid?
No, I mean, it's pretty close to one, but wasn't my point. What's the definition of an isosceles trapezoid?
One set of parallel lines and one set of congruent sides.
And one set of congruent sides. Okay, and then the property is that base angles are congruent. That was one.
How do we say sides instead of lines?
Because it's a shape. Lines go on. You could use the word segment, but I mean, once you're talking about things put together, we would call it sides usually. If you interchange side with segment, I wouldn't fuss.
No, I mean I like the word line more than side.
What does line mean?
It's
Exactly.
infinite. Line
Yeah.
is infinite.
But technically, all lines are infinite.
Exactly.
Yeah.
Line.
There's no line. There is no line.
If I use this is a line.
No, it's not.
It's a segment.
A line
It's a segment. It's just a longer segment.
There are no lines in nature.
And you know that
But
it-
there's
What
lines
about
forever.
volume?
There are no physical lines.
Universe.
Lines go on for
Yeah,
so
what about the
long
line of the
because they're so
universe?
infinite.
What?
The line that they don't exist.
Yeah.
The
Numbers
universe,
are
if
lines.
the universe is constantly expanding, then would
Yeah.
the
There are no physical.
Be constantly.
Lines.
Yeah, so there are.
I mean, because they have an arrow.
Give me an example of a physical thing
that
that goes on forever.
Right.
Physical.
No matter
Physical.
what.
Oh.
The number line's not a physical thing.
And actually,
The universe is physical.
So that means we can put a point in it.
Technically,
Can
Can
we just go on now?
Like the toddler's having a
yeah,
seizure.
when you start
Just
making.
leave the others behind.
So in mathematics, when you say, let's call this piece a segment, and then somebody says, what if it keeps going?
Well, then that's a line.
Then that's a
Ray.
ray. And then, so they start building on their thinking, right? You might be able to argue with me that there are rays in nature.
Yeah.
the equators are right.
Mm,
No.
Sides are right.
Though the sun creates rays. That's why they call them rays.
Light rays.
Oh, get that out.
Solar ray.
Wait,
You know how
that means it
X
would
and
be
Y
the
values
line
on a graph
where
might
Why
go
in
in
elementary school, Mr. McConnell?
Light dissipates
Mr. McConnell.
Well,
if there's nothing hitting it.
Mr. McConnell.
Okay, let's keep going.
Can I
Yeah.
ask a question?
Please.
Why in elementary school do they this is a line? Why do they do that?
They don't teach you the complex stuff. They
just say
they
it's a
teach-
segment.
they just
Wouldn't
teach you
light
simple
be a
terms.
line? Because it
It's
goes
a
on
ray.
forever?
It's got a starting point.
Yeah,
Mr.
it doesn't go on.
Mr. McCall,
forever,
you know how-
it goes through.
time is done?
Yeah.
On a graph.
I'm
in
talking
four
about-
quadrants, but
Yeah,
the
we're
X and Y
gonna
values
start
are
with
going.
Okay.
This is how maybe the X and Y values go out into the ground.
Yes.
So we can just put a point somewhere out in space.
Yeah.
That's some random infinite number that we don't know.
All right, let's refocus so we can get through this. So a rectangle.
Oh my God.
Did I miss something?
Are the top angles?
Those are also base angles.
Yeah. Oh.
Okay. Yeah. So we don't have to say it again.
Okay, never mind.
Rectangle, square, rectangle first. So, in my attempt in the warm up was to show for us to prove that what's special. Well, actually, let's define a rectangle first.
Two sets parallel sides, corner right.
Two sets of what? Not parallel, congruent. They are parallel, but that's not the definition.
And angles.
And all angles are 90 degrees.
But
All the sides are perpendicular to each other. Yeah. So properties. What property did we learn in the warm-up? Okay. All diagonals are congruent. So this one's special because the other ones, the diagonals weren't congruent. Okay. They bisect each other, but they weren't congruent. And that's it.
Okay, cool. What about the parallel thing? Parallel line.
And then it's a parallelogram, right?
Wait, all diagonals what?
Are congruent.
All sides are, congruent. Yeah, all sides.
I shouldn't have tried. I'm thinking back on the warm-up. I shouldn't have tried to prove that. I should have tried to prove that this triangle was congruent to this triangle.
Isn't that what you did?
No, I tried to do this one, which was bad. So then I could have said, I would have known that this is congruent to that, that's congruent to that, and that this angle is that angle. So a square. If a square is a rhombus, actually, let's do definition first, sorry.
All sides are congruent.
All sides congruent. All angles 90 degrees. So rectangle has a special property that the diagonals are congruent. Rhombus has a special property that the diagonals bisect the angles, and also are perpendicular bisectors. So the square doesn't have any special properties. That's unique to itself, but it has a bunch of properties. Okay, it's a parallelogram, so it's got those four. Okay, it's a rectangle, so it's got that property, and it's a rhombus, so it's got those properties.
All properties.
Okay, the only properties it doesn't have is the properties of a kite and trapezoids. Okay.
That's another shape we're talking about.
I would personally like to say rectangle, so +1. Parallelogram, +4. And rhombus, how many did I say for rhombus?
Like 6.
+2.
Max actually was 6, he's number 2. So he dropped 4.
Wait, couldn't we just plus 6 rhombus?
I mean, you could. I think it's better for us to realize that it's a parallelogram. Yeah. You need to know all the properties. I say square, and maybe this isn't the best way to do this, but you need to be able to tell me, okay, I know square. Consecutive angles equal 180. Diagonals bisect each other. Opposite sides are parallel. You need to be able to list off all those things. Okay?
Joyous. Johnny, what have you enjoyed today? You said joy like 3 times.
Very joyous occasion.
Sure.
Oh, okay.
Oh, yeah, we have that one really. Neat. I said neat.
All right, so let's look at this first problem here. We're told that we have a rhombus. My turn, please. Thank you. We have a rhombus, okay? And because it's a rhombus, we know that this angle right here is what? 90. I could put that on there and say that that's 90. We're looking for the measure of MNO. So we want to know what this large angle is. What's this angle going to be?
That's going to be
62.
Why? Yay.
Because diagonals bisect the angles.
Well,
Mr. McCall, can I do it?
The other side is 62 and 62.
So I was just told that this angle right here, this small angle, is 28. So the big angle, the answer to the measure of my brain is not drawing today. What is that? 56?
Because 28 times 2 is 56.
I know, right? I eat like not even a bowl of cereal for breakfast because I'm not hungry. And then
Help me with this next one. Hey guys, seriously, really? We're talking about what we're eating? Stop.
Okay, so
We know it's half of 5y minus
Yeah.
4.
Okay. So we have to set up an equation. What do we know is equal to something else?
3y minus 1 is equal to 2y plus 3.
How do you know that?
Because it's parallel or congruent sides.
Okay, rhombus has all the sides are the same, right? Okay. So then I can say that y equals 4. Did I do that right?
yeah, and then you plug it into the 5y minus
It's
4
16, so
over
it's
2.
8. QT is 8.
Okay, and then yeah, QT. What's the difference between QT and QT with a bar? QT,
is the segment, and then QT is just like
What's the measurement? of what's that?
distant. The distance, this means what's the distance of that?
But if we did put the line over on it,
I wouldn't.
why are you standing?
What is X, Y? Thank you. What is WY?
Oh,
okay.
I like this problem. You know what I like about it? It looks really easy, but there's a lot of work to it.
Oh, right.
I don't like it. I don't like work. Work is hard.
Okay, let's go.
Who's got an idea?
Oh, use the Pythagorean theorem.
Yes.
No, joy.
What? Joy.
Wait, why couldn't you use the
C squared equals A
Pythagorean
squared plus B squared.
What's this?
5?
5?
5.
So I'm going to figure out this triangle, this length right here first. Okay, so I take that triangle. I know it's a right triangle. This is 3, this is 5. I don't know what that is.
Oh, I can do that thing.
3 squared plus x squared equals 5
The answer to
squared.
that is 4, but you know what? That's where you get X, Y.
Yeah.
They love a very popular right triangle is the 3, 4, 5 triangle.
X is 2.
No.
What? I forgot about it.
What?
I forgot about it was 4. We did that last year too.
So that means the answer to WY is
8.
8.
What do you mean?
Yeah,
Okay, well, not even.
I mean, honestly, when I first looked at it, I thought you'd be able to go, oh, it's 5, or oh, it's 3, or
No, we're better than
No,
honestly, we're not.
okay, Mr. Smarty Pants, Mrs. Smarty Pants. You're gonna smack me.
No.
Yeah.
And that's a good thing.
Can you get arrested for that? Arrested for that?
Yeah, I'm like,
For what?
Mark telling me he's gonna smack me as hard as he can.
Yeah, that's Ryan Violet. That's like
You're missing
This
it.
one's 90 degrees.
I can't wait till you guys actually get it.
I'm gonna give you 30 seconds to see if you can figure this one out on your own. On your marks, get set, go. Go. 30 seconds. Figure this one out on your own.
Oh.
Close.
Close? It isn't? Because if
Okay,
it's like
go
that.
right. So figure. Show.
Okay,
I
where?
have an actual question. How do we know which points go where? Because
Um,
it's different on everything.
Is it?
Yeah.
Okay. Well, read it.
That's so
Try to figure it out.
So easy.
Oh.
Are you serious? It's a square.
So hard.
That's not that hard to
Got it.
try. Are you serious?
What is the answer?
45 degrees.
45.
What?
45?
40,
It's 45.
45
That is
degrees.
not diagonal.
Okay, it's either 90 or 45.
That was bad.
So if we know that AC is a diagonal
Oh, yeah.
Oh, I did the wrong.
and BD is a diagonal,
We never know.
and what's true about these segments? What do they do to these angles?
Bisect the angle.
Okay, and we know that they're all 90 degrees. So angle ABD is 45 degrees.
45.
That wasn't that bad.
I really
I did
don't
that in
know.
like 10 seconds.
So this isn't due the tomorrow of tomorrow. It's due the tomorrow.
I really don't.
It's not the tomorrow. It's not due Sunday. It's due.
So even though Monday is a work day, we're going to play maybe 1 or 2 rounds of quizzes,
Yay.
Cool.
okay, where we're going to need to be able to know these problems.